Okay, I think we are ready to get started. Let's see. Yep, audio is working great. Good morning or afternoon or evening, everybody. Gonna get right to the agenda. It's been about a month since we've met. Let's see here. So the first agenda item is testing, and I don't think we have anyone in here that can speak to testing. Is there anyone in here with updates for that? If not, I'll see if Dimitri joins later or anyone else who can speak to it. Okay, no problem. Let's see. The next item is the yellow paper. So the yellow paper was put under an open source license. Specifically, Gavin put it under the Creative Commons Free Culture license. So that's really good. That's an awesome step. And I think that that alleviates a lot of the problems we talked about last meeting. And so that's a good thing. I think Yoichi also had an update in the chat log. Let me pull it up. Yeah, so Gavin addressed the licensing issues, and there's been a lot of progress in it. Nick Savers specifically made some progress. So let's see. Anybody else have comments on that? I think that's an exciting development. I talked to some of the KVM team, and they weren't able to make it today, but hopefully they can make it next meeting for an update. Anybody else have a comment on the yellow paper issue?
Hi, Hudson. It's Ben. So it was me who kind of raised this a few weeks ago. I think it's great that Gavin's relicensed it, and that's a gift to the community. But the questions that I posed at the time kind of still stand in the sense of what will be what is the routine for updating it. Particularly, I'm quite interested in discussing whether EIPs should include an update to the yellow paper as a pull request, for example, just to make maintenance that much more natural and part of the process. So we don't need to discuss now, but if we can keep it on the agenda, I would be grateful.
Absolutely. Yes, that can definitely stay on the agenda, especially when the KVM team comes back.
Cool, thanks.
Wonderful. All right, anybody else have comments on that? Okay, so the next item, a community member wanted to get kind of an update on EWASM and specifically some EIPs that are related to EWASM or some other EVM efforts. So first, let's just do a general EWASM update. Casey, if you have anything on that.
Yeah, I'm actually here with a lot of EWASM contributors. So I'm going to hand it over to Alex, and he'll give the general update.
Hey everyone, we are here in Lisbon with everyone involved with WebAssembly from the foundation. We have Casey, Martin, Pavel, Jared, Hugo, and we have two external contributors, Silur and Jake here. Gonna say hello everyone.
Hey.
Big shout.
Hello.
Hello.
So the EEPs regarding EWASM, those can be disregarded. They are quite old. They don't really reflect anything up to date. But we have an org on GitHub called EWASM. And more specifically, there's a repo called Design on it. So if anyone is interested in getting a better understanding where EWASM is currently, they should go to github.com/EWASM/design. Now, in the last year, the design has been pretty much spec'd out, which has a couple of parts. And during the design work, there were two implementations parallel, one in JavaScript and the other one done in C++, which can be integrated with CPP Ethereum and Go Ethereum. Now, during the JavaScript work, there came up an issue, which is that in browsers, one cannot stop the WebAssembly thread, and there's no way to do certain operations in a synchronous manner. And the WebAssembly, the EWASM spec was written with synchronous operations in mind. So for example, store and sload and all the calls, all of those were synchronous. And that works really well if we would like to translate Solidity or Viper or even EVM bytecode to WebAssembly. Having all those operations synchronous really matches how we do EVM currently. But it turned out it's pretty impossible to implement that in JavaScript and to implement it in the browsers. So a new idea came up to move them to an asynchronous model. And the JavaScript implementation was changed to do that. And then there was quite a big break in EWASM in the last year. And now we have revisited all these design issues and implementations. And the bad news is we still don't have a full decision on the sync versus async. And Casey will tell a little anecdote about that after this. But so far it seems we are going with the sync version, at least for this sprint we're doing here in Lisbon. And the main point of this sprint is to finish the C++ implementation we have and to spin up a small internal testnet with 2 nodes running CPP Ethereum and proof of work, which will be able to run pure WebAssembly contracts in synchronous mode. It has another part we have yet to finish, is the metering in WebAssembly, which will be a contract itself. And this doesn't really rely on sync or async. Then I guess we need to make a decision on the sync and async soon enough, but probably we won't have a final say on that in the next few weeks. There's a lot other to tell about EWASM, but probably there's no point going into in depth because we could talk about it for days. So I just hand it over to Casey for the anecdote. It might be funny.
Yeah, we're prototyping using the synchronous API. So the asynchronous API adds some callbacks. And the primary reason for it was that if you want to use promises or fetches, or so let's say the contract calls an S-load, but the browser doesn't have that storage location already loaded, then it has to fetch it from the network and then return it back to the WASM instance. And the problem is that the browser implementations, or maybe it's the spec, the browser spec, does not, the WASM instance does not play nice with promises. And so that led to an asynchronous version of the spec. Now there's some alternatives where the EWASM spec can remain synchronous, and then things get a little bit clunky in the browser. And so one of those alternatives was to use web workers and a new JavaScript feature called atomic.wait. So because Node.js doesn't have web workers, that won't work with our testing, all our testing scripts, which are Node.js based. But at least it would work in the browser. At least it would have worked until these past couple of weeks. That feature atomic.wait. Alex and Martin had a call with a V8 developer, and he informed them that atomic.wait is now disabled in the browser because of Spectre and Meltdown. Those CPU flaws.
Oh no.
Yeah. So I don't know. So we're putting the. It would have been nice because then we could, use the synchronous API would work, and we wouldn't have to worry about doing clunky things in the browser. But now we have to. Well, we're going to proceed prototyping with the synchronous version, and do clunky things in the browser.
Okay, awesome. Thanks for the update. So what I gathered from that, 3 sub point A talked about the EVM 2.0 EIP, which I believe is number 48 from December 2015. Martin, can we can you go in and close that or deprecate it within the EIP's repo?
Sure.
Awesome, thanks. So that deals with subpoint A. Subpoint B is something with extending dupe and swap, with dupe in and swap in. So that is from Matt DiFerente. Can anyone comment on that and what that would have to do with EWASM?
It has nothing to do with EWASM. It would be extra opcodes in the current VM.
Okay, and yeah, Greg, I see you've commented a little bit on that, and so is Christian.
And
Is
so
this?
is Alex, I think.
Yeah, and Alex. So, what do you guys think of this? Is this something that needs to go into, I guess, a protocol change of some kind? I don't understand the technology or the technical stuff enough for it.
What about it?
Well, it's an upgrade to EVM 1.0. If we jump straight to EWASM, then it's not needed.
Right. It depends on how long we think EWASM is coming, how hard it is to implement this, and how important it is.
Okay, and the last EIP would be 615. That's the one for subroutines and static jumps for the EVM that Greg's been working on. I think this is for EVM 1.5. Is that right, Greg?
Yeah, that was authored by myself, Christian, and Pavel.
Okay, so I guess I'm not up to date on where we're at for EVM 1.5 with EWASM. Is this something where there's going to be EVM 1.5 and then transpilation to EWASM, or is it still kind of up in the air? What's going to happen?
I have no idea. I haven't been on contract since September. So I've been working with Seed. I don't know his real name. He's works with Yoichi on just cleaning up that proposal at a formal level. He's writing a LEM formalization of it. He's very interested in getting that part in. What will come of it, I have no idea. We haven't really discussed it, and I don't think we have any particular mechanism for any social practice for making a decision on this. It'll happen somehow.
Okay. Christian, what's your opinion?
Yeah, I mean, the main problem is that we don't really know whether it provides a speed up at all. And the amount of implementation work needed to get a speed up is probably multiple years. So
No,
looks like WebAssembly is a better alternative.
Yeah, the speed up comes with 616, not 615.
Okay, got it. So let me go to that one real quick.
So, but we could debate it here, but there's really not time. This is 1 hour with a bunch of other stuff, and a proper discussion would take a lot more time.
Sure, no problem. I was just more wanting to get like an overview of everyone's opinion on it and kind of where all of them are at.
Since the work has been pretty much unfunded since June, I would say it's not going to happen in this release. I've got ideas for a 3.0 that pulls everything together with transpilation, but I haven't worked it out and nobody's paying me to do it right now.
Okay, sounds great. Let's see.
Years.
The next item, let me pull up the agenda again. Okay, so that kind of covers those EIPs. Is there any other comments on EWASM? That's a lot of good updates from the team there. Okay. Item 4 is stateless client development. Someone just said they wanted to hear any updates on that. Does anyone have any updates on that? I think it was more, there was a blog post explaining it and there was some discussion last time, but I don't think anyone took it upon themselves to research or perform anything further on it.
Hello, it's Alexi here. I just wanted to shortly say that Piper, who didn't join the meeting, I think he left some comment in the agenda, no, in these thing about that there is some development of stateless client, but I understand it is for the sharding, because that's actually when Vitalik talks about it, he mostly talks about stateless clients and the sharding. And I think some people refer to my proposal to do stateless clients before that. And I I kind of got distracted from that because I realized it will incur quite a lot of overhead in terms of bandwidth. So when I have more data, I will come back to that.
Okay, great. Thanks, Alexi. And everyone, welcome Alexi to the Core Dev meetings. He's been working on what he calls TurboGeth and has been active and kind of breaking down the protocol in a way, or not breaking down, but I should say improving the protocol and researching some speedups in Geth. Okay, cool. So that's the update for stateless client development. The next one would be adding ECAD and ECMOL precompiles for SECP 256K1. That's an EIP that Matt opened, and I believe it's just an alternative to the precompiles we recently added in Byzantium, if I'm not mistaken. These precompiles, it's been argued, would be a speed up, and let me see the comment that was posted inside of the agenda. There's a comment from Mobius, a development team that's doing ring signature privacy solutions. Or actually, the team's not called Mobius. I believe that's their product. It's Clearmatics that's actually working on this, from what I understand. So they basically argue that privacy on Ethereum is too expensive. They have a blog post about it, and I wanted to get everyone's opinion. I know that we talked about this months ago, and it was some pretty positive. People had positive reaction to potentially adding this, if I remember correctly. So does anyone have comments?
I can comment on why it is as it is currently with the precompiles.
Yeah, that'd be great.
So ECAD and ECMAL was never intended to be used for general purpose cryptography. It was intended to be used in conjunction with the pairing precompiles. And since the pairing precompiles are for a specific curve that is pairing friendly, that's the reason why we chose exactly the same curve also for ECAD and ECMAL.
Okay, and so would it be detrimental or add extra weight to just add these precompiles, because then that would kind of lead down a precedent of adding any precompiles people want, or is this something that is like widely used enough that it would be valuable?
Yeah, I think that has to be discussed, but in general, I think we said what we do not want to add, or I mean, yeah, perhaps not do not want to add any precompiles, but yeah, there has to be a really compelling reason to add a precompile.
Okay, understood. Anybody else have comments?
Yeah, I have a comment here from Seiler.
I don't know the plans about this ring signature stuff after the blog post. You know that we are working on a new ring signature with the Monero research team and called String City or Rough City. We still didn't decide which name we will go. And we also have working Java implementation on our repository if you are interested.
Great, yeah, if you could post that into the core dev channel or into the chat in the Zoom later, that'd be great. And who'd you say your name was and where you were from?
Silur, Hungary, Abraham Endre. I'm doing eWasm stuff and Ethereum JS since I think February or something.
Okay, great.
I was the one with the paper problems. Anyway, it doesn't matter.
That's right. Okay. Yep. I think I have talked to you before, definitely.
Yep.
Perfect. Okay. Well, great to meet you on this meeting. If I haven't met you before, apologies, or haven't remembered that I met you before on the core dev meeting, apologies. Any other comments on that, on those pre-compiles and opinions?
So perhaps the eWasm team could give an opinion about how efficient a eWasm implementation of that would be, and if there is any rough estimate on when eWasm would be ready in general.
We don't have recent benchmarks, but the last benchmark we had was regarding the SHA-256 precompile, and the speed, I don't have it out of, I don't fully remember, but it was a factor of like factor of 10 slower. So the code written in WebAssembly and metered using the WebAssembly rules was consuming probably 10 times more gas than the subsidized gas we have chosen for the precompile. But that was a single example for SHA-256. And probably we were really bad at choosing the subsidized gas values for everything, every precompile we have. The only time we will be able to comment about this when we write them, compile them to WebAssembly and meter them and see the outputs.
But what about the execution speed itself?
Well, that really depends on the actual VM implementation one is using. There are probably 8 or 9, likely even more, implementations of WebAssembly VM. There's at least one JIT, which should be really fast. Are there any, Martin, are there any benchmarks comparing all these VMs?
The fastest one is Wobble. That's
well, that's a JIT.
Yeah, it generally gets 1-2% overhead overrunning native code.
So apparently the JIT implementation of WASM can go up to 2% overhead over native x86.
We can't use a JIT. Cannot.
Yes, we know.
Okay. Then why are we measuring these JITs? Do we have a non-JIT solution in mind?
Are we on?
No, I'm just
curious
what's wrong with it.
What's the problem with the JITs?
They're a DDoS attack vector.
So we don't have an upper bound on the compilation time, and neither on the compilation time, not on the result of the compilation, on the performance of the result of the compilation.
Is this been a practice?
Thanks.
I can't see that.
Okay. Is this in practice been a problem?
It's been discussed quite a lot. Nick Johnson can lay it out in quite some detail.
We can actually use a JIT, but it has to be a special JIT that gives a promise about its performance, and that's usually not the case for JITs. I might be wrong there, though.
Well, Yeah, JIT's designed for web pages don't have this issue with DDoS that we do.
And you said Nick can provide more feedback on this?
Yeah, he's been arguing it more than anyone else that I've noticed.
Okay. So that'd be good post-meeting to kind of bring him in on this.
Yeah, Christian's aware of the issues. I just wanted to know what the fallback was, because all of the performance claims are based on, well, not all, but if the performance claims are based on V8, they're not directly usable.
Mm-hmm. Okay. And did the Ewasm team answer all your questions, Christian? Or to the best of the abilities that we know of the information right now?
At least I don't have any further questions.
Greg, weren't you doing benchmarks?
Yeah, I presented those at DevCon. On my to-do list is to turn over to Dimitri the test code that I used. It's
so
current.
The WASM code you tested there, was it run on a JIT?
I'd have to go back and check. I think I used WAVM, but I don't remember. I'd have to go back and check.
Please do if you have a chance.
Yeah, I can also down in the C++ test. Yeah, within the C++ repo, down the test directory. Yeah, I'll send you a link.
Yeah, there's also the point that it's not, I mean, there's the comparing the performance of WASM to native, but then there's also comparing performance of WASM to EVM 1.0. So even if it's not as fast as a native precompile, it's probably still a lot faster than what it would be when implemented in EVM 1.0.
Yeah, as far as speed, it was very close to native. So the issue is just it needs to be done. The compile, you have to compile at the time you load, at the time you load the contract. You can't do it as a JIT unless the JIT's pretty carefully designed for the purpose. Even then, I think there's a pretty big risk of an attack vector.
Yeah, I mean, the problem is, no, we don't want to implement more precompiles because each precompile needs a custom metering implementation or a custom metering rule. And it gets more complicated and it requires a hard fork, and it would be better to just switch to a better VM so that we don't have to, discuss, precompiles anymore.
Yes.
I mean, it's not only the metering, it's the fact that we require a specific implementation for each of the precompiles, and there might be differences in the actual implementations and the chance of an unintended hard fork.
So it sounds like benchmarks need to be had in order to figure this out completely, or to make arguments for or against the inclusion of these, in EWASM versus in the EVM.
Just back on the precompiles, I mean, it's one thing that there needs to be multiple implementations, but if I remember the Byzantium precompiles, it took quite a while to figure out the actual subsidized gas values for them. Partly, of course, because the implementation differences. So that may be an important point. If we have like WebAssembly metered, then we don't need to figure out those subsidized values.
Is that something that Martin did when right before Byzantium, Alex? Was that his estimations?
Yeah, it was a couple of people, including Martin Smendi.
Okay. I remember
I
he
think
was
it,
the one who was updating the repo, but yeah, there were a few people, definitely.
yeah, yeah. There are
So also,
multiple reasons for WebAssembly, probably other reasons against it, but we never properly weighted which properties are more useful to us. And the speed, the benchmark speeds is only one property out of that. Definitely need to be benchmarked again, because any benchmarks done were probably done 2 years ago or a year and a half, and a lot changed in the WebAssembly specs since.
Okay, sounds good.
so also perhaps another generic comment on precompiles and VM and things like that. So adding a new precompile would only give us a constant speed up or a constant reduction in costs. And if we can achieve the same or a similar thing with an improved virtual machine, it will get us much further, because an improved virtual machine gets this constant speed up for every conceivable routine. And furthermore, it also gets this. So furthermore, with this speed up, it allows us to implement other scaling schemes like Plasma and TrueBit, and yeah, just this generic verify a blockchain state transition of another chain inside the virtual machine. And this is much easier with WebAssembly, because we can use existing C or other code to do that and don't have to rewrite it.
Okay, that sounds good. Yeah, that's a good point, and I think that it sounds like the consensus amongst those who are implementing a lot of this stuff within the virtual machine is that it would not be a good use of time to implement these precompiles in our current EVM compared to working on a newer virtual machine that will have these same cost benefits that they're looking for, at least that they describe that they want in the blog post. Okay. Any other comments on that? Okay, the next item on the agenda, item 6, introducing minor heuristic child pays for parent. I have a little bit of info from a comment on the agenda, but I'll have Alexei introduce the concept and what his idea is behind that.
Yes, so it's just to get people's opinion on that. So what I've noticed a couple of days ago that so if you go to Etherscan and then if you inspect the pending transaction, the tab, and then it's sorted by the gas price in descending order, you might notice that very often on top of that, there would be some transactions which are hanging there for probably like minutes and hours, which pay like 1,000 gig away of fees. And so when I drill down to it, I realized that some of them are, actually most of them are the, the transactions which are dependent on the other ones via nonce. And the ones that are basically they're dependent on are paying really small fee. And that's didn't look like an attack to me, but somebody just making a mistake. So they would send the first transaction with a very small fee, and it wouldn't be mined. And then instead of replacing that using like the wallet, they would just send another one with a huge fee, but with the next nonce, and none of these transactions will be mined. So and if you're familiar with the Bitcoin, you probably know that there's this thing called the child pay for parent. So I'm not sure how much benefit we're gonna get in Ethereum from that, but I thought it might be an attack vector that you might want to close out. So that's basically it.
So the problem with that is that in Ethereum, basically I can specify that I have a transaction, I give it 3 million gas, and I give it 1,000 gigabyte of transaction fees, but basically the miner has no guarantees that the transaction will actually consume 3 million gas. So the only guarantee the miner has is the transaction will consume 21,000 gas, basically a plain ether transfer. Anything above that is just hoping to be consumed. So it means that if basically the attack vector is that I push in a transaction which truly consumes 3 million gas, and I push it in with, for example, 1 way, and then I push in another transaction which I say consumes again 3 million with 1,000 gigaway, sorry. And then from the outside, it would look that I could execute both transactions for 500 gigaway. And in reality, my second transaction will immediately return, so the miner will almost get nothing out of it. Whereas the first transaction will be extremely long running and the miner gets penalized for it.
Yeah, I understand that. It's just whether it's worth a trade-off, because it is possible to basically fill up the mempool with lots of these pairs. I'm just wondering if there's any impact on the clients because of that.
So, not sure I understand the question. So, if there's
so basically, like what I can do now is as an attacker, let's say, I can just generate lots of lots of pairs of transactions. Like first transaction with non-zero will be paying a very small fee, let's say 1 gigaway, which will not be mined for days and days and days, and the second one with the nonce1, which is going to pay a higher fee. And I can generate lots of those, and then they will be stuck in everybody's mempool for a very long time. So I just wonder if that's the problem.
Well, currently, at least in Go Ethereum, we maintained about 4,000 most expensive transactions. So if your transaction is too cheap, so to say, to make it into the top 4,000, then it will get evicted. And once your cheap transaction gets evicted, your expensive transaction gets evicted with it because it's not executable anymore.
Okay, I understand.
So this way, currently, you cannot really attack the network with it.
Okay, thank you very much.
Mikhail, do you have any comments on how the Java client handles this as far as mempool and what it does with smaller transactions?
Not now. I guess I have to go to watch in the code how it cope with that. But I suppose it's pretty same, like Go does it.
Okay, sounds good. And did that answer your question, Alexei, about feedback for the item?
Yes, it does. Thank you very much. Yeah.
Great. Okay, the next agenda topic. So there's been discussion lately about creating a relay network of nodes to mitigate issues. And just some background on this. Also, Griff did a comment recently about 9 hours ago that's near the bottom of the agenda. Major issues with transaction propagation. There's a channel that has a lot of major exchanges that kind of help each other troubleshoot transaction propagation issues. And because of how many transactions they're pushing out and a lot of the problems they're having getting their transactions into Ethereum right now because of the increase in popularity, people are looking for different solutions. One of those being a relay network, and I know Alexei has some knowledge on this because he's been discussing some of the detriments of having a relay network of nodes that directly connect to each other, mainly because that would create a kind of privileged network and make less of a mesh network that would not benefit small miners. So Alexei, can you kind of define what people are talking about when they say a relay network, and then your opinion on why that wouldn't be a good idea?
I mean, I'm not an expert in this subject, I must say, but that's just what I've been kind of. Maybe I'm completely wrong in my assumptions, but what I understand, the relay network, as far as I understand, is some kind of high-speed connections or direct connection between the major miners, so that they never really produce the uncle blocks, because they can just route transaction to each other directly and very fast. And so, and that would improve the uncle rate and probably will bring it to zero. But then, it's is the danger is that if I'm a small miner, I mean, I have to first get into that group, otherwise my profitability will be smaller because I will have to be on the periphery, and I won't be included into this like a powerful ring of players who are just giving each other transactions very quickly. So, and I don't know, at the moment it looks like the Ethereum, because of these high, people don't like this uncle rate, but I think it might be the sign that it's still a mesh network. It didn't actually form that like a ring of powerful miners, which I see is sort of a good thing, but it's kind of the other. There is another side of the coin. So that's why I think we need to try to improve the network without creation of the second like isolated another super network, because we want things to be homogeneous, and that's just my opinion. Maybe some people will say that this is all I mean, I have no wrong assumptions here, but yeah.
Yeah, is there anyone else who has any opinions or want to correct any definitions that were just discussed?
So one of my questions actually is regarding what the issue actually is. So is it a block propagation issue or is it transaction propagation issue?
So it looks like it is a transaction propagation issue, is what my understanding is, and that's what Griff is describing in here. So it's transaction propagation out of networks and nodes with, or not networks, nodes with high throughput, so like Bittrex and Infura. And so that's kind of the issues that have been going on. What I've kind of seen in there are exchanges that suddenly the clients stop relaying the transactions, or they're not able to push out the transactions fast enough.
I'm just getting some more feedback from other channels that, so my kind of the flaw in my definition is that I'm assuming that this relay network will only connect miners, but I think the idea was also that this relay network will include other kind of operators like exchanges and things like this. So maybe that changes the picture. But from my personal experience, I must say that I've synced recently a node, and it's got like a huge SSD drive, and it does actually struggle to keep up, and then very often it just drops out to the network, has to catch up, and I see that the other people experience the same thing, and
Yeah, so a lot of it, people just kind of make the assumption that clients like Geth and Parity aren't designed for high throughput, and that causes transaction propagation issues. I know Geth's been working on some of that, because there's been some fixes before for issues that have been filed by exchanges, but I didn't know, Peter, if you had any other comments on that, or if you've noticed any of the same issues.
No, so since the last quite a few releases, we haven't heard any particular issues that would target guests and transaction propagation itself. I mean, so no, perhaps no. Well, one thing that what we could check is how different clients propagate transactions, how many transactions different clients keep. For example, I can describe how Go Ethereum handles transactions and how it propagates them. I'm not sure how Parity does it, because, for example, if there's a conflict between how the two of them do it, then maybe. So worst case scenario, Geth filters out some transactions, Parity filters out some other transactions, and at the end, only the lowest common denominator gets through. So it might also be something like that. So it would be nice exploring whether there's by any chance some conflict, or what the different queue limits are for Parity and Go Ethereum.
Yeah, and I know Martin's been communicating with some of these nodes and people who operate nodes that have high throughput of transactions. So we can get you in touch with some of these people as well, to kind of get there. So they've been doing some issues in GitHub, and sometimes they're harder to describe, I feel like. So we'll get you in touch with them specifically. But that's a good point that if the two clients act differently, that could be detrimental to some people who are pushing out a lot of the transactions from one address, and maybe they're getting filtered out. Any other comments on this? It looks like there's just going to need to be more exploration on the scope of this problem, and so we can get better definitions maybe for the next meeting. Okay. The next item on the agenda, fork release management for Constantinople. We had discussed release management before, something like, I think it was 2 meetings ago, the meeting right after DevCon 3, and that what was brought up is maybe having more of a project manager, or borrowing from some release schedules that other projects perform, where they do releases every X amount of months, like 6 months or 8 months, and doing that for hard forks, so that we define parameters for what goes into a hard fork after a certain amount of time, and then give them enough time for implementation and testing. I think that's still a good idea. I'm back working full hours at the Ethereum Foundation, so I may have some time to start to write up some stuff about that. And there's a miner who does some videos on YouTube named Bitsby Trippin, who sent me some really good documents outlining some of the possible ways that we could improve our processes. So I'm going to look at those more. Does anyone else have any comments on like maybe when we should do Constantinople, and the ideas around having a release management process within Ethereum for hard forks? Okay. When we have more people in here in the next meeting, we'll probably discuss more about Constantinople. Between now and then, I might try to round up some of the EIPs that are meant to go, that are potentially going to go into Constantinople. The most popular or discussed one being account abstraction, and whether or not that is still going to happen. I think the general consensus was that it was a very difficult problem to solve, but that it was something that people wanted. Does anyone remember kind of where we came to on account abstraction the last few meetings? I know I have it in notes somewhere.
There's some new threads on the ETH research forum about account abstraction, and that's kind of where the discussion has left off.
That's right. Vitalik wanted feedback on that. Okay. So yeah, let's go next meeting. Let's collect the feedback from that and have Vitalik or other researchers discuss what came of that thread to see if we're any closer to cracking the problem of figuring out the best way to perform account abstraction or implement account abstraction. Any other comments on release management, Constantinople, account abstraction, or anything else we just talked about? Okay, let's go ahead and get to client updates. We'll start with Geth. I saw there was some tweets from you, Peter, about some cool new features that are coming out in Geth 1.8 and some speedups that you've been able to do since our last core dev meeting where we discussed that. If you want to elaborate.
Yeah, sure. So feature-wise, well, I'm not sure. It doesn't necessarily affect the entire ecosystem. Rather, it's nice features that we're trying to do. For example, a nice tracing API so that anyone can write their own little JavaScript tracers and run it. So you could also do that previously, but we put a lot of effort to clean that up. We also put a lot of effort now to, so even until now, we could generate Go APIs for contracts. So you could just plug in either the ABI or the Solidity code, and it could generate you a Go wrapper around it. Now we have the same thing for working for events too and subscriptions. But these kind of were the niceties, and probably the rest of what at least I and a few others will be focusing on for the next release is somehow to make Geth a lot more performant. Nick had this idea way back that we mentioned a few times on the CoreDev meetings, which he kind of paused on, and I picked it up now. It's actually, the idea-wise, it's really nice. It's kind of solid. It has a ton of corner cases, but it kind of seems that we managed to reduce the database writes both by quantity and disk IO-wise by about 60%. So this won't help initially sync a node, but it will at least make your disk fill up one third of the time as fast as previously. And apart from that, we're also kind of Jolt is exploring a few garbage collection ideas that would also entail reorganizing our entire database. We kind of tried to do that a few times. Usually the limit is that fast sync doesn't. So the way fast sync was designed, it's really horrible from the perspective of garbage collection. So we're actually thinking about figuring out how we could do garbage collection properly, or how we could speed up the database properly, and then just roll a brand new synchronization to aid it. So, but that one would probably affect the network a bit. So we're just trying to play around with ideas and probably make a proof of concept. And if it turns out to be worthwhile, then we'll probably get to EIPs or somehow try to get some feedback from other clients too. Because I know, for example, that as far as I know, Ethereum J and Harmony, they also implemented fast sync. So that's how they also sync. And if we're all of a sudden will be unable to provide data to fast syncers, then basically we're kind of killing Ethereum J, and we don't want to do that. Anyway, so that's what we've been up to. Oh yeah, and we are aware of a memory issue during sync. We were trying to fix that, just so that people don't freak out.
Okay, sounds good. Thanks for the update. Next, let's go with the C++ team. Let's see. Christian?
Hello.
Yeah, I will say something. So I think
Yeah,
the only big item on our work is Andrei work on snapshot imports. This part has some good progress. The rest is some fixes, cleanups, and so on, and EVMC updates to make EWASM integration easier. I think that's all I have to say for now.
Okay, thank you. Next, is there anyone from Parity in the room? I don't think there is. Okay, let's go with Harmony. Mikhail?
Thanks, Hudson. Yeah, regarding your previous question about pending transactions, I just double checked with the code, and there are some different logic Ethereum J implements, and if transaction hasn't been included in a certain number of blocks, it's just evicted from the pool, so it doesn't matter. It doesn't address to a reason of why it has not been included in the block. So yeah, that's how it copes with that. Okay, and some updates from us. We have started to work on Casper implementation, and on the other hand, we are still fighting for performance improvements. We have met some difficulties that haven't been expected by us, and we plan to release database improvements first, and in the next release we are planning to work on reducing memory footprint and improving processing speed. I'm afraid to make any estimation regarding database release, but this is #1 priority for our team. So as soon as we manage that, it will be released. That's all from us. Thanks.
Thank you. Okay, Ethereum JS.
Mainly the same updates we gave earlier. Well, the entire Ethereum JS team is focused on the EWASM right now.
Okay, sounds good. Thank you. Let me just check to see what clients I'm missing. I don't think anyone from PyVM is here, but I know that Piper left an update, so I'll just read that. Where did he put that? He said that implementation of full node sync and PyVM is underway. The foundation for running PyVM as a stateless client is going on. Implementation for a simplified eth-gas station pricing algorithm is in progress for web3.py, and an alpha release to PyVM based client is happening. He also said that the research team may or may not be there, but sharding and research development continues, which I know that they're helping a little bit with. They're doing a little bit in collaboration with the research team. So that is the PyEVM update. I believe that is all of the clients. Are there any other clients or major projects that want to give an update? Lexi, if you wanted to talk about TurboGeth at all and where you are in that, feel free. Otherwise, if you don't have much of an update, we can.
No, I give you a couple, some sort of data that I've collected. So first of all, I want to say that the kind of my plan with this is that just to first of all to experiment with some optimizations I can do. Of course, when I did the fork of Go Ethereum, and then started making changes. I broke a bunch of stuff like Light Client and all like a fast sync. They absolutely don't work at the moment. So, but I don't worry about this because I'm just experimenting. So a couple of things that I wanted to analyze, and I have some data now. If you saw my list of the improvements that I wanted to check out, so one of them was the reducing the state size on the disk, and the idea there was that so the way that the state is stored on the disk, there is a lot of repetition. So lots of hashes are written multiple times. And so I'm currently running like the analysis on the full state until yesterday. But before that, I was running the smaller set. And so the data I had was, so when I synced to the block 2.2 million, and it extracted so there was about 100 million state tree full nodes, and I extracted about 75 million unique hashes, which were contained in those nodes. And so then I counted how many times each hash, unique hash is actually repeated on a disk. And the most frequent hashes were repeated 669 times. And then I did some analysis of like, if we were, let's say, hard code some of the hashes in the memory, let's say, just out of interest, and how much disk space we're going to save by that. And I mean, I had this graph, which I might give you later on. But basically, you can get up to 20 gigabytes savings on the disk, but that would require you to hard code 32 million hashes, which is could be quite a lot. And another data point that I have for you is that another idea was to reduce the memory usage for these hexary trees that we have. So basically, the state of Ethereum is stored in these hexary trees, and so in the TurboGeth, in the client that I'm currently trying to hack around, is that I'm trying to, as much as possible, keep the state in memory, never, if possible, never actually touch the disk, so that everything, and I'm trying to push it to the limit. And so what I realized that I analyzed that, how many nodes are actually like fully occupied and not fully occupied. So if you look at all the nodes in this hexary tree, so about half of them are the actual leaves, the values. Usually they're connected through some so-called short nodes, and another half is they're called full nodes, which are basically like arrays of 16 elements, and they're kind of, if you imagine this visually, there will be on the bottom there will be all these values, and then on top of them there will be like sort of pyramid build up. So the weight of this pyramid is approximately the same as the weight of the bottom bit. And so if I look at the tree, which corresponds to about block 2 million, then there will be about 140,000 full nodes, which are these the 17 cells elements, and there's 151 value nodes. And but the interesting bit is that out of 140K full nodes, there are 44,000 nodes, which is a third, are only with the 2 children. So this is was my suspicion before. And then there's a similar amount of nodes with the 3 children. So here there's a potential for improvement by, especially storing the nodes with only 2 children in a more compressed way, so that we can spend even more memory on holding the state. So my hope is basically, at least for the initial sync, to try to basically fly through the first 4 million nodes if it's possible, just using the memory without even touching the disk, only for writes, of course, but not for reads. So that's what I'm trying to achieve at this moment. That's it for me.
Great, thank you for the update. All right, I believe that is every client and project that needs to go over stuff. I have client improvements to alleviate issues, but we kind of went over that with the client updates and some of our discussion on actually what you just described. Someone also wanted to add to the agenda, this is Griff again, updates on scaling. So will we see any scaling improvement from Constantinople? We don't have finalized EIPs yet for Constantinople, so that's not really a question we can answer concretely. But he also asked if there's going to be improvements because of Casper FFG. So let's see here, guesses on the time frame for scaling improvements. So because there's a lot of network congestion right now, and the people are finding that in order to get their transaction in, in under a few minutes, they need to pay high fees, that people are wondering about scaling. So does anyone have any general ideas about scaling and whether or not Casper's going to alleviate some of that, or if we're going to have other improvements outside of client optimizations?
Casper is just consensus protocol, isn't it?
That was my understanding.
So I don't really see why Casper would help with basically what we need. So scaling is more, so currently we're kind of limited about database and processing stuff due to being limited by the database. So whether we run proof of work or Casper, that kind of just boils down to wasting or not wasting GPUs on it. But I don't think it matters much from a block processing standpoint.
Yeah, that, and he actually, Griff even said, I expect this not to be the case, but it's worth asking. So anything else with Constantinople that would have that we've discussed as potentials for going into Constantinople that would alleviate some of the issues they've been having with scaling?
I mean, since disk I/O is the bottleneck, and it's still not clear how much room we have to optimize, by optimizing the database, how much more gas per second, the average or even high-end computer, will be able to process. I think there's still plenty of room, at least to verify, hit the limit on disk I/O by optimizing the database. That's the most important thing right now.
Okay, great. Thanks for the answer. Oh, go ahead.
Short term, I kind of agree, but I think it's important to know that so basically we can optimize the database, and let's say we make it 10 times faster or more optimal, which gives us room to grow for our 10 times our current size, but eventually we will get back to the same point where we won't be able to do any database optimizations anymore. And by that time, we need to be able to shard our data apart.
Does anyone have any updates on sharding? I know that that's ongoing research and there's been a lot of progress, but Vitalik wasn't able to make it today to give an update. Has anyone heard any updates?
There are some really interesting threads on the ETH research forum about the state tree. So the Merkle tree format that will be used, for sharding. There's some interesting ideas on these asynchronous accumulators or Merkle mountain ranges that sound very promising. So there's a lot of exciting proposals that are being discussed.
Great. So to answer everyone's question about where Constantinople and sharding is at, some of those can be answered by going to the ETH research forums. So that's good information. Someone also mentioned in a comment they wanted to talk about the decision process for EIPs. That is something that I also want to work on, hopefully in Q1. And that specifically what that means is kind of updating EIP1 a little bit more, because I know there's been a lot of confusion about where ERCs fit in. And Casey and Nick and others have talked before about doing some improvements. Greg too, about doing improvements to the EIP process. So it definitely can use more improvements. We've added an EIP editor, Nick Savers, on GitHub. He's been doing a great job cleaning up the EIPs, and Yoichi has also been added as an editor, and he's been doing some cleanup of EIPs. So we've been kind of trudging through that a bit. And I hope to dedicate more time personally to it in order to get some of that done, which I've said before, but this time I actually feel like I might have the time. So that's hopefully going to be good. So as far as the decision process goes, community consensus and then the editors getting enough time to go in and actually merge the commits are the kind of how it goes down, which EIPs go in and which ones don't. But it should be noted that if you have an ERC or an EIP that you've created, it's good to actually start implementing them even before they get officially approved, because part of the criteria for certain EIPs is having example implementations. So for example, ERC20 token was implemented well before the EIP was actually finalized. So I know that CryptoKitties, I think, had EIP 770 or something around that number for non-fungible tokens implemented before the EIP will be finalized. So having an implementation like that in the wild is very positive for your EIP getting approved. That's all I have on that. Is there any other comments on EIPs? Okay, great. Any other comments on anything else that's not on the agenda or anything anyone else wants to say? Okay, well, thanks everyone for joining. We'll meet back up in 2 weeks. Hopefully we'll have more people around and some representation from some of the research team and Parity and others so that we can get more updates and dive into some of these issues a little bit deeper. Thanks everybody. See you in 2 weeks.
Thanks everyone.
Thanks everyone. Bye-bye.
Thank you. Bye-bye.